Hello, this is Felipe Fregni. This is Medical Teaching, Learning and Innovation. This is Lecture 2. My name is Felipe Fregni. Again, this is MTLI. This is Lecture 2. We are discussing neural principles of learning. And today we will be discussing short-term versus long-term learning. So this is a very important topic, and you can think the following way to make it easier, and I'll just discuss the main topic. So if I do ask you, and that's something as an educator you should always be thinking, what is my goal? Do I want students to learn short versus long term? So, and what I'll discuss here briefly as a complement to the other readings is what are the mechanisms for short versus long term? So what are the differences? How can I have it a short versus a long term? So that's what we will be discussing here today. So let me start with a simple example so you start understanding a bit more about brain functioning. If I ask you to memorize 6 numbers, and I'll write here just to make it easier to understand, but this exercise works just telling the numbers. Of course, if you use visual memory, it becomes easier to remember. But if I just ask you to memorize, I'll just ask before writing it down. 1, 3, 4, 9, 7, 6. Okay. And if I ask you to repeat, you may repeat it. Especially if I ask you before, you have to repeat after me. But then again, 1, 3, 4, 9, 7, 6. And then you may repeat it. And then if I come 2 hours later or next day, likely you will forget. Unless I say, for instance, this is important for you and you need to remember next day and you keep practicing and practicing and practicing. But at one point, you will forget those sequence of numbers. So again, 1, 3, 4, 9, 7, and 6. Okay. And why do you forget this? So this was at one point in your short-term memory, or you can put it this way, you can call this as well as a working memory. Okay. And here it's there's not good, we still don't know much about, again, mechanisms of short-term memory, working memory versus long-term memory. Sort of there are a lot of unknowns here. So, but just to discuss this again. So again, and you can translate these to anything, and we'll try to translate after. So if I ask you to memorize that again, and I ask you to repeat, you will, but you will forget these numbers, and it's very likely that a lot of things that you are doing sort of in your day-to-day and hearing, you will forget. Why do you forget? So some people say, oh, because brain, it has this mechanism of erasing what's not important. That's not true, of course, and it's not the brain that decides what is important or what's not important. It is you that decides that. And remember one thing, so if you learn something, so why is it so difficult to memorize this sequence for the rest of your life? It's not because the brain has this adaptive mechanism that this sequence is not has no evolutional meaning, that if you don't remember this will represent a disadvantage for you, an evolutionary disadvantage for you. No, it's not that. It's because if I just tell you 6 numbers in isolation without any meaning, that's the reason you can't, it will be difficult for you memorizing. However, if I come to you now and say, look, think on the sequence now. You start with 1, that's the first number. Then think on 0 to 9. Or let's take 1 to 9, that'll be easier. So thinking on 1 to 9, and then 1 is the first number, and then I give you the second number, 3. Okay, 1 and 3. So then if I tell you to memorize this in a following way, so 1 plus 3 is 4. Okay, so again 1 plus 3. Then I ask you to do a mirror image of this one. So the mirror of 1 is 9. The mirror of 3 is 7. The mirror of 4 is 6. So again, first number 1, and then I gave you a random number 3, and then 1 plus 3, 4, and then the mirror image here, 9, 7, 6. Okay. If I give you this rule, and if I ask you tomorrow, you may be able to remember. And it's much more complicated. You see now how many mathematical operations you need to do it, but this has a meaning. So what happened is now it is easier to remember because it has a meaning. And it's different than 1, 3, 4, 9, 7, 6. Or someone can remember by doing all the other things. For instance, so 13 is my number of my lucky number, 49 is the number of my house, 76 is the age of my grandmother, for instance. Okay, so if you think on this way, so that may be easy. And again, and what happens when you give meaning? What happens when you give meaning to a sequence here? When you give meaning, you're connecting. So, and when you connect something, and it goes back to our lecture 1, when you're connecting two concepts, okay? So when you're making a connection, okay? So you're connecting a neural network, it's easier to remember. So you can go any node of the network to retrieve that information. So that's the thing. So again, of course, if you're interested in short-term memory, if what the interest is you have 20 students in a classroom and you want them to memorize 1, 3, 4, 9, 7, 6, and you ask it in the exam next day, and if they keep repeating without any meaning, likely most of them will get a full score, especially this is very easy. But if you do want it, this should be long-term. So then, yes, then you need to make a meaning of that. So that is the key here, that you need to be thinking here when you're thinking on short, when it's bringing something short to long term, is when this new piece of information, suppose this is the new piece of information, and this is 1, 3, 4, 9, 6, 7, 6. This is connected with something else. Then you'll be able to easily remember something. And that's something, and again, and here it comes, when you think in short to long-term memory, there are a lot of factors that are involved in making this as long-term. But as more meaning you give to the new information, so I think a few things. So the meaning you give to the new information plus this sort of how your students connect in terms of their previous knowledge, that is the key for that to become long-term. Okay, so that's what you think. And then yes, there are several neural processes we'll be discussing more that are involved in making a new information becoming something that's in the short term becoming long term. And you say, so is it just repetition? And I think that's an interesting thing. Just repetition works. It works again in short term. Repetition by repetition, short term. However, meaningful repetition, then it's a different thing. So alone, it doesn't work. But meaningful repetition, it does work. For instance, you give a different meaning every time you. So now let's say we go to these numbers, and again, as I said, so you say 13 is the number, whatever one else, 13 something, an accident happened, and so on. So then if you start giving meanings to this number, likely you remember very easily this number. Okay, and of course then you can say, oh look, but I have a password that is a very complicated password. There is no meaning, and I do remember. You do remember because you keep it alive in the short term. So what happens is, again, in the short term, if you think on two neurons here, okay, so you're connecting two neurons, so neuron A and B, okay, and then let's say you're repeating the information, the numbers, and you are connecting. So these neurons, you have a transitory increase in excitability of the circuit, excitability, okay? And when that happens, it's very easy to go there and remember those numbers. For instance, a password that you use it. But let's say you stop using this password for 2, 3, 4 months. What happens? This excitability, it decreases and you can't remember anymore. Unless, again, there was a meaning for that, okay? If there was a meaning for that, then this information will be easier to be remembered. And thinking here as well on an example is, for instance, a course of anatomy. How to get the students to understand basic principles of anatomy, not just memorizing the name of arteries, the name of bones, the name of muscles. That's the thing you should be thinking as well. What do you want your student to learn? If you spend 6 months in a course of anatomy, just for them to memorize and repeat a name of a bone, it's waste of time. Okay, because they'll not be learning anything new. Okay, so that's again, it's how you want to modify what they know. You don't want people just to repeating. You want them to understanding. Okay, so we'll discuss more this week, and then. You have 2 videos to see it, and also an article, and we look very much forward for the discussion this week. Again, thank you, and we'll see you in class.